Cosine rule. The reason we're doing the cosine rule is the sine rule wouldn't work for us. Another indication of the cosine rule is the following. If you're given a side and the angle in between and another side, it's an indication you're doing the cosine rule. Okay, so once again, the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. For part 3, small a is going to be x, so that's x squared. Small b can be 5 and small c can be 6.8. So it's 5 squared plus 6.8 squared minus 2 times 5 times 6.8. And then you have an angle of cos 105. Now, prediction time. In this question, what would be a reasonable answer? Anything above has to be above 6.8. Why does it have to be above 6.8? It's looking at the largest angle, so therefore it must be the largest sides. Okay. So if you don't get that, you're in trouble. So you put it all into the calculator. And 2 times 5 times 6.8. I'll tell you now. Exercise 3.5. Who got 88.84 roughly? X squared equals 88.84. That's way too large. We forgot the square root, obviously. Square out your answer. 9.43 will do me nicely. Okay. Everybody cool with that? It says 1 decimal place in the question, so I'll just do 9.4. We all good? All right. Did anybody get that out before you left class? An angle question, all right? And I will take part A. That's okay with you guys. Now, would everybody agree that A is looking at the largest angle in the triangle? Everybody agree with that? It's got to be around the 90-degree mark somewhere. It's got to be the largest angle in the triangle. Okay, that's the first thing we know. Now, this is not a length question. This is an angle question. And with angle questions, I'm going to ask you to do the following trick for me. Here's the trick I want from you. You work a protective barrier around this. See this part here? It has a protective barrier around it. You don't go near it till the end. Everybody cool with that? Yeah. That's the agreement. They're bonded together by multiplication. That's why we can't go near it to the very end. So here's what we're going to do. Okay, if that's big A, what's small a? Small a is 12. It's whatever big A looks at. And the other two can be B and C, whichever one you decide. Let's do this. 12 squared equals 7 squared plus 8 squared, and then 2 times 7 times 8 cos A. All right, 144 equals 49 equals 64. 2 times 56 is minus 112. Now, once again, what did I say about my protective barrier? Still surrounding that part there, isn't it? Okay. Now, here's what we're going to do. See the 49 and the 64? We're going to take that away from what number? We're going to take it away from the 144. When we bring them over, they're going to be negative, aren't they? All right, guys. So what happens when we get 144, take away 49, take away 64? Huh? 21. All right. I'll go for that. Now, lads, what's the goal of the question again? A is what? An angle. What's the only way you finish angle questions? Cos inverse, sine inverse, or tan inverse. So let's get cos A on its own. How do you get cos A on its own? The minus 112 goes underneath, and what happens? What? Turns into division. Turns into division. Now we all get our calculator out. We press shift, cos inverse. Now what were we expecting? We're expecting to have the biggest angle in the triangle, aren't we? And let's find out if this fits our narrative. Is 106 guaranteed to be the biggest angle in the triangle? Why? You only have 180 to play with. and that's responsible for 106. So therefore, you definitely have the largest angle in the triangle. Cool. All right, I did one. You guys are gonna do. You guys are gonna do B. Is that okay with you guys, lads? Page 115 on the sheet. Now, lads, look at this. The only two things you have to decide at the start of the question is what's your angle and what's the side that looks at the angle. What angle are we looking for? What angle are we looking for? B. So this here is going to turn into B. And what side looks at the B? There you go. They're the only two decisions you have to make, really, and then the rest of it just falls together. So what's A and B? And what are the other two sides? 20 and 16. Let's lump them in. And please remember your protective barrier. Always use protection, lads. Go for it. Okay, 14 squared is 196. That's 400. 16 squared is 256. Yes, it is. That's minus 640 cos B. Once again, I'm just going to keep in mind that I'm not allowed to do anything with that for a minute. Okay, bring over the 190. Bring over the 400 and the 256, and take it away from your 196. We're going to take away the two of them. Who got minus 460? Equals minus 640 cos B. Okay, now I'm going to grab that 640. All right, lads, I'm going to throw that underneath. So minus 460 divided by minus 640 equals cos B. I'm going to cos inverse that. And our prediction is a small angle, not a large one. So something below 60 degrees, I reckon. You could, but oh, and they're both minuses, aren't they? Yeah, technically plus. Okay, 44 degrees. Am I correct in saying we can? All right, guys, 1, 2, and 5. All right. Now, let's look at what it wants from me. It wants QS, so let's find our target. QS is this one here. Everybody see it? Now, would everybody agree that QS is actually a member of both triangles? It's a member of the triangle on the left, and it's also a member of the triangle on the right. Now, what you got to decide is which triangle should you use, left or right? Well, we're going to use both, but for the first question, right has more information, doesn't it? Now, right has more information. Okay, let's see if we have all the information available to us. Could anybody tell me what is this red angle here? 98 for everybody, yeah? Now, here's the deal. We have two choices in our arsenal, don't we? We have A over sine A, we have B over sine B, or we have A squared equals B squared plus C squared minus 2 BC cos A. See if the sine rule works. If the sine rule doesn't work, pick something else. So let's see if it works. X divided by what? Sine. What looks at the X? Yeah. Pick another side we know the answer to. Oh, that's enough. Yeah. Grand. I'll pop 3.9. All right. So lads, to one decimal place. 3.96 goes up to 4. So, okay. So X equals 2 sine 98 over sine 30. And what people at home are saying is, was it 2? It rounds off to 4. All right. Rounds off to 4.0. We cool? Now, lads, what's the target in What's the target in our next part? PQS. P to Q to S. Where is that located? Everybody agree with this purple angle here? Not including the 52. Without the 52, yeah? Great. Give it a letter that's not currently in use. A would be a good one, wouldn't it? Because it's actually in the formula, isn't it? Now, if that's big A, what's small a? And you can call B 3.5. We could call C for what type of question is it? Angular length. It's an angle question. Go on. You're doing an angle question now. Okay. So, times 3.5. You could just, if you want to save yourself a bit of time, you could just do 3.5 squared plus 4 squared and just one go in your calculator. Save yourself a bit of time. What's a good prediction for our answer? Huh? Yeah, it's going to be the biggest angle, I think. Okay. Now, want to get cos A on its own, Dominic? How'd you do that? 14 divided by minus 28. Cool. I'll cos inverse that, won't I? It's at 28. 150? No, I don't think it is. 120. 120. Now, does it kick that answer straight out? Oh, does it? Happy days. Yeah, 120. We'll take that. Okay. Okay. You're not too sure, you can draw yourself a little diagram. 6, 4, 5. Theta is the one that's opposite the 6. Then you're just going to write down your cosine rule. How did I know it was a cosine rule question? Yeah, I have no, if I use the sine rule, 2 parts are going to be missing. So I have no choice. All right, guys, fill it in and get cos theta on its own. So we call you big A. We're technically big A. That's 4 and 5. All right. Get this on its own, and then get cos theta on its own. 41 minus 40. Bring the 41, take it away from the 36. Gives me minus 5. What's minus 5 divided by minus 40? Minus 1/8. Oh, sorry, an 8. We got cos theta equals an 8. 1 over A. All right, now here's the deal. Take question 2. It wants you to find out what sine is, yeah, doesn't it? We know what cos is, but it wants us to find out what sine is. What? Back to SOHCAHTOA again. What does cos mean again? Anybody remember? Okay, let's have a look at this, all right? So, silly old Harry chased a horse through our attic. And if this was, you can represent any angle with a right angle triangle, okay? And what we're saying is that this is a right angle triangle. This is technically your adjacent and your hypotenuse, yeah? That's your 8, and that this is your 1, and this is angle theta. How do I find this side here? We call it Pythagoras theorem, will we? I'll name it y, for argument's sake. So what's it? 8 squared equals y squared plus 1 squared. 64 equals y squared plus 1. 63 equals y squared, and then root 60. What is root 63? Somebody said earlier. 3 root 7, yeah? Okay. 3 root 7. Okay. Now, how do you find sine theta then? Sine is what, lads? Opposite over hypotenuse, which is what? 3 root 7 over 8. And that, long and behold, that's our answer. Okay. Quick here, unfortunately. Okay. So, let's read the very first line. When you see area in the trigonometry chapter, what's the formula that jumps out at you? See, right? What two sides do you have to use? What are the only two sides you know? Huh? You only know 3.2 and? Okay. And see this angle here? For argument's sake, I'm going to call it x. Is that cool with you guys? So what sine? What's the area? 10. What's going to be your goal now? Get sine x on its own, and then sine inverse it to find the angle. Is that all right? Okay. Now, it wants the answer to 1 decimal place. So do your angle to like 3 decimal places, okay? So this part here in blue highlighter, lob that all into the calculator. Thirteen, 14. What do you reckon now? Yeah. And where does it go? Under. Sine inverse. Get. So 10 over 13.44, yeah. $48. Yeah, 48.1 will do it there. Well, that's actually not the answer actually. So that's one step. So instead of x, I'm going to write down 48.1. What chapter is this about again? This is about the cosine rule. In this question, have we used the cosine rule yet? No. So that's a good indicator when you're doing your homework. If you're in the cosine rule chapter, if you haven't used the cosine rule yet, something's wrong. Okay. So what do we need to do now to find out the length of the red side? Call it small a, do you? Right, and therefore call that large A if you want. Okay, guys, take out the cosine rule then. this a length question or an angle question? Length ones are easy. You can just throw it all into the calculator all in one go. No hassle. Who got 6.7? Full marks. You need to add them all together. You need to add all three sides together for the perimeter. So some people start celebrating then and there, just giving away 3 marks, even though you knew how to do everything. Add the 3 green parts together. What you get, Colin? What? 18.3. Okay. Now, imagine a solid block, and what we do is we slice the edge off it. Okay, so you saw the yellow parts sliced off, all right? Now, don't get too bogged down in the trying to understand. Like I overthink these a lot, so I don't know if you guys are the same. But what I'm saying is calculate the angle PQR. So here's what I'm saying. I need to find out what PQR is, all right? Now, what's the issue with that? We have nothing, okay? So it's not great. So I'd love to know what PQ is. I have no idea what that is. I'd love to know what PR is, but I have no idea about that either, do I? Go for it. Oh, look, my man. 3 right angle triangles. Look at this one. Okay. So does everybody see, we'll start with the top one. Does everybody see this green triangle here? Right angled, isn't it? So here's what we're going to do. This right angle triangle, who said bog standard? Disgraceful. Plagiarism of what I say. Now, lads, would everybody agree that each length is 10? Every length is 10. So can anybody tell me, what is this blue length here? If that's 2, what's the blue length? 8. Awesome. And what would this red length be? 5. Pythagoras' theorem will find you. Pythagoras' theorem will find you PQ. Do you get it? And then you have to do it again for PR. You're going to have to do the exact same thing for PR. What is the length of the green? What's the green length here? 6, isn't it? So that's going to be, what's it, 8 and? It's going to be 8 and 6, isn't it? So that's going to be, what's it, 8. That's going to be 6. And this is PR. And the last one, lads, what's the last one? The last length we need to know is QR. Q to R. And that will be a 5 and a 6. Okay, your job is to, yes, yeah, do Pythagoras' theorem 3 times and figure out what is the length of each one. Okay, so 8 squared plus 6 squared is 100. The square root of 100, 10. Got that? 6 squared plus 5 squared, 61. Square root of 6, just use the square root of 61. So that'd be the square root of 61. So QR is root 61. PR is 10. And the last one is 8 squared plus 5 squared, 89. And then we square root that to get root 89. Now, does everybody see those numbers there? Okay. But once PQR, which one's PQR? The purple angle there, yeah? We'll call it capital A, for argument's sake. Okay. Largest angle or smallest angle? What's 10 squared? So root 100 is bigger than root 89. So it's the largest angle. So we're going to have to figure that out using the cosine rule. We haven't used the cosine rule yet. That was a difficult question in the end, wasn't it? Three right angle triangles, and then you had to. That's capital A, that must be. Small a. Small a is 10. Angular length question. So what do we do then? So I have your protection system, yeah? Okay. That's going to be 100. The two of these combined is going to be 150. The other part I'm not too sure about. 2 times root 89. You want to put the decimals, are we? Grand. Yeah, no bother. 147.36. Take away the 150, it's minus 50. We're expecting the largest angle in the triangle, somewhere close to the 90 degrees region. Cos inverse it. And, oh, yeah, I would have got that wrong actually. Minus needs to be clearly on top. 70 degrees. 70.1. Is it one decimal place or is it 70 degrees? All right, that's so